Hey, finance students, welcome to chapter 6. We are looking at annuities. Now we are going to include the payment option. Be looking at, instead of just a single sum payments, we're going to be looking at continued payments over time. And when we talk about annuities, we're talking about financial sums that include a recurring payment of the same amount at set intervals over time. So to do some calculations of those, we're going to add one more argument into our present value, future value calculations, and that is the payment option. So that PMT that we will see here, this PMT that we have here, now includes a recurring payment of some kind, whether it's like a car payment or a house payment, credit card payment, or if it's just a gift that we get every year from somebody. It can include any of those things. So if we're going to calculate future value of an annuity, of a recurring payment, we'll do so like this. So let's look at the first couple ones here on ICA 6A1 that we see. Okay, if you invest $1,000 each year at 8%, how much would you have after 3 years? Now, one of the assumptions that we make with a typical annuity, there are two kinds of annuities. One is an ordinary annuity or a typical annuity, and the other one is an annuity due. With an ordinary annuity, one of the assumptions we make is that all the payments are made at the end of the compounding periods. Whereas an annuity due, which we will talk about in ICA 6.4, I believe, an annuity due is an annuity where you get payments at the beginning of the compounding period. And we'll look at the calculations for both of those. So if it does not indicate payments at the beginning of the period, or if it doesn't say it's an annuity due, we assume an ordinary annuity. So for this one, if you invest $1,000 each year at 8%, how much will you have after 3 years? So with any of these problems, we need to have at least 3 inputs in order to get the fourth. So let's start with that. So what we see here is we are starting out with no money. It doesn't say you already have $1,000 in the bank or you already have a certain amount. No, it does not say anything like that. So we have a present value of 0. Our interest rate, which we see is an annual interest rate. If it doesn't specify other than annual, we assume it's an annual interest rate given. Number of periods, again, would be 3 years. And now we have our payment. So if we look at that, if you invest $1,000 each year at 8%, so we're going to say that is $1,000 that is coming out of our pocket. So now we have a recurring payment of $1,000 coming out of our pocket. We want to know how much we would have, in essence, in the bank or we'd get back after those 3 years. So we have our inputs. We know in order to find future value, we use our FV function. We plug in our rate of 8%, comma. We plug in number of periods of 3. And then we also know, I'm going to make this a little bit bigger here. Well, maybe not. We know our payment is actually behind here. So there's kind of a trick to get to. If you go to click on the cell that's beside it and use your left arrow, you can actually sneak in behind it that we have there for payment. And that's what we need, D8. So you hit enter, and that tells us that after 3 years, we would have $3,246.40. Let's do another one. Let's do the second one here. Your Gammy decides to give you $100 at Christmas each year. If she does this for 4 more years, how much will you have after 4 years if you invest the gifts of 10%? So again, we're looking for a future value. How much will you have after 4 years? So that indicates some time in the future, a future value, the value at the end of the compounding periods. So we look at that. We see here, she's going to give us $100 at Christmas each year. We start out with 0. It says we don't have any. If you can invest it at 10%, so that's our annual rate, and we're going to do this for 4 more years, and we know our payment's going to be $100. So let's say you take the $100 and you put it in the bank. How much would you have after 4 years? So again, with any of these problems, it's really good to do timelines to draw these out. If you're not sure how to draw a timeline for an annuity, go back to the PowerPoint slides. I show you detail how to do that there. Okay, so we're going to use our FV function because we're calculating the future value. We want our rate of 10%. Number of periods is 4. Payment is 100. Our present value is 0. You don't have to include 0. If you want to, you can plug it in there. It doesn't matter. It will calculate it the same way. Once we have those, we can hit enter, and we see that we have a future value of $464.10. Why don't you go ahead and work on the rest of these here and see what you come up with. The answer keys are given to you